So, today we're going to talk about the most complex map in existence, the one of your own mind. But here's a thought. What if the map you've been using your whole life is just, well, wrong? For literally centuries, scientists have been trying to draw a map of the brain. And this image right here, it kind of gets at the new reality they're facing. It's this vibrant, overlapping, and deeply interconnected system. It's not a world of neat, clean borders at all. So this is really the big question we're digging into. Think about it. We all have this kind of mental model of how our brain works, right? But what if that model is just fundamentally flawed? And what if it's actually misleading us about who we are? Right, so to understand where all this is headed, we've got to start with the old map. The one most of us probably learned back in school. This is the world where every single mental function has its own little piece of real estate, its own clearly defined territory. Psychologist Lisa Feldman Barrett has this perfect analogy for this. She says that for the longest time, neuroscientists drew this map as if the brain was just a bunch of Lego blocks, each function neatly assigned to its own separate piece. Click, click, done. And you totally know this map? The prefrontal cortex? Oh, that's judgment happens. The motor cortex handles movement. Temporal lobes, that's memory. Visual cortex, sight. A neat little place for everything, and everything in its place. It's simple. It's elegant. And, as we're about to see, it's just not right. But here's the thing. Under the powerful lens of modern science, this neat and tidy map is starting to completely fall apart. The borders are blurring, and what's emerging is a reality that's way messier, and honestly, a whole lot more interesting. Okay, so here's the real bombshell. Brain functions aren't neatly contained. That whole idea of a specific memory zone or a dedicated perception zone, it's getting blown to bits by all this evidence of massive overlap. So it's less like a map of different countries with hard borders, and way more like a single, huge, bustling city where all the neighborhoods just bleed into each other. This quote from Barrett, again, really just nails the brain's incredible ability to multitask. She says a single brain network can have more aliases than Sherlock Holmes, just popping up all over the place to do all sorts of jobs you'd never expect. And the evidence for this? It's absolutely staggering. Think about something super simple, like just moving your eyes from one side of the room to the other. It turns out a full 2/3 of your entire brain gets involved in that simple action. 2/3? That's not some little specialized center. That's like an all-hands-on-deck, system-wide event. And it's not just that. Get this. Half of your brain is active when you're just breathing. Just the simple act of respiration. The sheer scale of this cooperation just completely shatters that old Lego block model of the brain. This problem is so deep, it's even challenging the very words we use, our scientific language. Researchers have found it's almost impossible to design a test that can cleanly separate perception from memory. The two are so tangled up that the categories themselves might not even be real, meaningful distinctions in the brain. And look, this confusion isn't just some academic debate. It has real-world consequences. Let's take a closer look at the amygdala, which has been famously, and as it turns out, incorrectly, called the brain's fear center. So for decades, right, the story we were told was that the amygdala is what makes you feel fear. But neuroscientist Joseph Ledoux has been arguing for years that this is just wrong. The new science shows us the amygdala is actually a subconscious threat response system. It creates a physical, behavioral output. Your heart starts racing, your palms get sweaty. But that conscious feeling of being afraid, that's actually constructed somewhere else, up in the prefrontal cortex. And this is exactly why this distinction is so incredibly important. Because if you develop a drug for anxiety that targets the amygdala, you might be able to stop someone's heart from racing, sure, but you won't actually touch the feeling of anxiety itself. This simple mix-up is literally holding back progress in treating mental health conditions. Okay, so if the old map is broken, how in the world do we draw a new one? Let's check out what some of these rebel cartographers are doing, the scientists who are trying to chart this brand new territory. So what are the new game plans? Well, there are a few different approaches. Some scientists are digging into our evolutionary history, trying to see how these systems evolved over time. Others are trying to map how the brain combines different bits of information, not just single functions. Then you've got people studying the brain as one big interacting system. And some are even turning to machine learning, basically letting the data itself tell us how the brain is truly organized without our old biased labels. Now, to see how this new way of thinking works in the real world, let's look at a really fascinating discovery. It has to do with something called sharp wave ripples. These are basically little bursts of brain activity that happen in the hippocampus. And for a very long time, we thought the hippocampus was pretty much just for memory. But then, a recent study found that these so-called memory ripples are also absolutely essential for, wait for it, regulating your blood sugar. Just let that sink in for a second. A super high-level cognitive process like memory is directly tied to a basic, fundamental metabolic function. The old map of the brain, it could never ever have predicted a connection like that. No way. So, okay, we're definitely getting a much more accurate picture of the brain, but this new, more complex knowledge, it kind of comes at a price. It's not just challenging our scientific models, it's challenging our very understanding of ourselves. Neuroscientist John Krakauer brings up this really fascinating, almost philosophical point. He asks, as our scientific knowledge gets more and more detailed, more granular, do we actually start to lose our understanding of ourselves? I mean, if we can explain something like love as just a series of chemical reactions and electrical impulses, do we lose something really important in that translation? So, I want to leave you with this final question. In this incredible quest to create a perfectly accurate map of the brain, are we maybe losing sight of what it means to be human? Is the correct answer really useful if it doesn't answer the question we actually had in mind in the first place?